I'm going to start the recording. We're being recorded. Vector equations. Let me make this a little smaller so you can see it. All right. So I'm going to let you copy this down. Now, in your notes, like vectors, how many have seen vectors in physics or Calculus 3 or another class? Vivian has, and Mohammed, and Francesca, and Robin, and Binyam, many of you. Excellent, excellent. Well, in this course, when you have in the notes, and this is in the book too, thank you everyone, when you have a bold symbol, bold means vector. So this here, the way you would write that on your paper, and for the first exam, first exam notation is also important in addition to showing work. You're going to use a vector symbol. I don't want this symbol. I know this symbol has been, how many have seen this symbol for a vector? Kind of the upside, yeah, in calculus, but we are not going to use that here because we're gonna need this symbol later on when we look at some statistics. Okay, applications. Well, essentially they are statistics applications. So we're not going to use that notation. I want you to use the vector notation, this. So in your notes, when you write vector A1 equals 1, 1, use the arrow notation. Please use the arrow notation. Okay, and I'll let you copy that down. So we're going to talk about what a span is. We'll talk about it. It's good to see everybody. Well, the one person hopefully will come back, but it's good to see everybody in class. Remember, class participation is very important. Every time, that's important because when you're participating, you're helping other students in the class as well. And for recommendations, I always address whether the student attended class and participated. So very important. So it's good to see everybody, and that's good. Okay. So all right, we have these vectors. A1 equals 1, 1. Vector A2 equals 1, negative 1, and vector B equals 2, 4. And we want to know if this vector B is in the span of A1 and A2. Okay, so span means, of course, to reach out, right? Like a bridge spans over a river. And in order, well, when we go to the solution, you're gonna see what we have to do to see if the vector B is in the span of A1 and A2. So I'm gonna go to the next page now. Is everybody Good so far? All right, I want to make sure I'm pacing myself so everybody can have time to copy the notes and all of that. Excellent, excellent. Okay, so, all right, to see if a vector B is in the span of two other vectors, we need to see if B, the vector B, can be written as a linear combination of the vectors A1 and A2. Okay, and we express that sentence mathematically this way. Let me give you a chance to copy this. Okay, so section 1.3 deals with vector equations. And vector equations are equations that have vectors in them. So, and you're going to get a geometric feel for what a span is in a moment here. But basically, if B is in the span of these two vectors, A1 and A2, then B would be able to be written as a linear combination of A1 and A2. So that means that, well, linear combination means some variable x1 times A1 plus another variable x2 times A2 equals the vector B. And we can solve for x1 and x2. This is our vector equation, and we write that in terms of notation. We write it just like this. So now, are there any questions here? All right. So, of course, we want to relate vector equations back to what we learned in sections 1.1 and 1.2, where we solve a system of equations, right? So, okay, well, let's see if I can do that. Certainly, a scalar, I mean, x1's a variable, but it's a scalar variable. I can take vector a1 and multiply it by x1 and then get x1, x1. And I can take vector a2 and multiply by x2 and get x2, negative x2. Okay, certainly we can do that. All right, so what are the dimensions on these vectors, by the way? How many rows, how many columns? What are the dimensions? 2 rows by 1 column. So I'm actually uh, I understand what you're saying. You're thinking of combining them. Okay, all right, good. So they're all 2 by 1 vectors. Can I add 2 vectors if they're the same size? Can I add 2 vectors? Is that allowed? Absolutely. Absolutely. Okay, well, I'm going to add the 2 vectors on the left. Okay, so then I'm going to get another 2 by 1 vector. Are we good up to here? Let me know if you're uncomfortable. Okay, well now, for these 2 vectors, thank you, Solon. For these two vectors to be equal, what must be true about x1 plus x2? X1 plus x2 has to equal what? Has to equal 2, right. Good. What about x1 minus x2? That has to equal 4. Oh, okay. Well, hey, now we have our system. Now we have a system that we're going to try to solve. Well, we don't have a 2 by 3 matrix here. Oh, I see what you're saying. Yes, that's right. What Binyam's saying is we could make an augmented matrix with 2 rows and 3 columns. Absolutely. That's what we should do. That's right. Christy likes that. I can tell. She has her happy face in her chat window there. I don't know. All these emojis look, I guess there are some emojis that don't look happy, right? But they all kind of look happy. But I'm sure. All right. So, okay, I'll move to the next slide. Are we good? All right. Avi likes that one. Okay, same as Christy. All right, well, let's solve the system. All right, excellent. Let's solve the system. Let's do some row operations. So here's the augmented matrix. And we'll use the skills that we learned and try to get this augmented matrix in reduced echelon form. The 1 here is a pivot. So we're going to take -1 times row 1, add that to row 2. Okay, and then replace the second row with that result. And we get here. Okay. Of course, I want this -2 to be a 1, so I'll take -1/2 times the second row and replace the second row with that result. And of course, by row, I mean equation. Okay. And then to get it, we need to get a 0 in this spot here. So finally, I'll take -1 times the second row, add it to the first row, and replace the first row. I don't want to get my picture messed up here. Replace the first row with that result. Maybe I'll put it below it here. Okay. So now, well, this matrix is in reduced echelon form. I mean, that's we can't have any better than that. And so we can identify in this case, since it's two equations with two variables, we get a unique solution of 3, -1. Well, I should say we get one solution. And this means then that 3 times A1 plus -1 times A2 is equal to the vector B. And I'll talk about that picture in a moment. But let me just get the words taken care of. And so therefore, B is in the span of A1 and A2. Well, Solomon, you just have to, the echelon forms, it's going to take, hold on here. It's going to take some practice, and of course, you know, doing the working on that past homework assignment will really help a lot. It'll really help a lot. Everybody's going to have a chance to. I mean, most students are in my math lab, but everybody will have a chance today to, you know, again, we'll have some classwork time, and then, you know, my math lab will be there. But Solomon, you can't really. I mean, to learn this, I want to say this the way I want to say it. But once you do enough of it, once you do enough of these row operations through like the section 1.1 assignment, I think you're going to feel better about this. But the reduced echelon form basically means you're getting the matrix in as simplified form as you can get. That's what reduced echelon form is. That's what it means. Francesca, question?
Yeah, I have a question. Can you hear me?
I can hear you. I can hear you.
Okay. My question is that I'm still having like also trouble like getting all the way to the reduced form in the homework, but how much points would we get off on a test if, like, let's just say we can't get to the reduced form, but we still can get the value of like x1 or x2 by basically like, for example, you get like one reduced form, like a 0, 0, 1, 3, and then you can plug in.
It'll be significant. Now, you know how much, I don't know, but it's not a little thing. Getting it in, okay. and you know, if you can get it in echelon form, then you can get it in echelon form, right? The matrix.
Yeah.
It's just going the other way. That's a little harder, right?
Yeah, like getting it all the way reduced. Sometimes I can get it all the way reduced, and sometimes like I mix myself up, and then I get back to like a worse point, or sometimes back where like not where I started, but sometimes I'll get like 2 1s in the same row, and that's a problem.
Well, you know, with I think, Naima, with practice, you will overcome that. I
Okay.
mean, you know, I know you, and you know, you, I had you in calculus too, right? And
Yes.
so I know that, you know, I think you can overcome it. But what I'm saying is, with a little more practice, let's see what happens, and then see me at office hours too, and
Okay.
we can, you know, maybe go over one of those that aren't, you're not quite getting to the end. How's that sound?
Yeah. Sounds good. It's just more like critical thinking, you know, like you actually really do have to think about the, like different
Yes.
patterns and stuff.
Yeah. This course is very different. Well, it's different from calculus in this. Well, calculus, believe me, calculus 3. There's conceptual stuff too,
Hmm.
but you know, it's a different, it's more conceptual, this course, in a sense, probably, than, like, I want to be careful because calculus is also conceptual, but this, I don't know, it just requires more, a little bit more conceptual thinking, abstract thinking. I guess that's the word I'm looking for. Yeah.
Yeah. Well,
And
thank you.
geometry. So, and oh, you're welcome. And you know, geometry. Binyam mentioned about geometry. Well, look, we can actually interpret this using this picture here. So what I've done is I've drawn the vector a1 and a2. Okay, I've drawn the vectors. So a1, remember, a1. Let me just clear that. Hold on. A1 was 1, 1. So the coordinate 1, 1. I don't know why that's not. Hold on. Let me just hold on here. Click, click. Okay. The point 1, 1 is in the first quadrant, and I plot the point and I draw the vector. Yeah, I think we've unless there are there any questions. Well, what I'm trying to do, here is, so I'm telling you that that the vector b is in the span of a1 and a2, but I want to show you geometrically why it is. Okay, anytime you can write a vector as a linear combination of other vectors, then the vector is in the span of those other vectors. Okay, that's what the definition in the book, you know, says in a way. That's what it says, but in a more mathematical phrasing. But here, I've drawn vector a1 and I've drawn vector a2. A2, the vector is 1, negative 1. And then you have the vector b. The vector b is equal to 2, 4, right? So what this says, remember what we have here. We have 3 times a1 plus negative 1 times a2 equals b1. So what am I doing here? All right, I'm taking the vector 3. I'm taking the vector 3. I'm taking the vector a1, and maybe maybe I'll put it in blue. Here's a1. How many a1s is that I've done? This is a1. That's 2 a1s, right? That's two A1s. Then now I have what? How many A1s? Three. Three A1s plus a negative A2. Well, A2 goes, this is A2 right here. It's separate, this is separate from the picture. This is A2. So negative A2 would be it would be this, right? That's negative A2. I'm trying to draw it the best I can here. Head to tail method, exactly right. So here's negative A2 right here. So you're adding, so that shows then you end up by doing 3 times A1 plus negative 1 times A2, you end up at the point B here. And so A1 and A2, the span of them is, B is in the span. In other words, by taking a linear combination of the A1 and A2 vectors, the vector B is in the span of A1 and A2. It can be reached, it can be touched by a linear combination of A1 and A2. And we call A1 and A2 the spanning set. It's a spanning set. As a matter of fact, any vector in the x1, this is x2 here. Any vector in the x1, x2 plane would be in the span of A1 and A2. How many kind of like this geometric interpretation? Does that help you feel a little better about? Good. Yes, Binyam's right. They reinforce each other and it should make more sense. Absolutely. Are there any questions? I want to do another example, but are there any questions on this one? Let me know. Have a chance to draw the picture there. Incidentally, the picture I used a straight edge, a protractor with markings. You know, you have to do that in order to get a good picture. I could ask you for a geometric representation, Moshe. Sure, I could. I could ask you to draw a picture. Sure. If the equation came out to be 3A1 plus 1A2, to say it's asking, yes, then B would be in the span, because if you can write a vector as a linear combination of A1 and A2, then that vector's in the span of A1 and A2. All right, let's move to another problem, okay? We're good here? Good questions. You're welcome. I want to say Gazib. I hope I pronounced that right. Sega. All right, thank you, Sega. Okay, let's do another problem. Hold on here. All right, let me give you a chance to copy this down. Okay. Now, do these vectors, they don't live in R2, right? We have, we talk about spaces in linear algebra. Okay, I mean, we have, how many have ever seen something like this, R2? Yeah, though that's two-dimensional space. Matthew says the vectors live in R3, and they do. They live in three-dimensional space. And we want to know if the vector v is in the span of these two vectors. Is the vector v in the span of A1 and A2? Okay, well, let's go ahead and find out. Are we good with the example? May I move to the next page? All right. Okay. All right. Hasten myself here. So just like the first for the previous example, we need to try to solve this vector equation. Hold on, let me put this in blue. Does x1 times a1 plus x2 times a2 equal a3? Equal b, sorry. Right, so we always start out with the vector equation. So like on your first exam, this kind of question for the work, I would want to see the vector equation right at the beginning. Okay, sometimes I've seen students, I mean, we know this vector equation is gonna be then converted to an augmented matrix, right? But you should not start the problem with the augmented matrix. You should start it with the vector equation, because that's, you know, where's the augmented matrix come from? It comes from the vector equation. And that's what we're, you know, using here. All right, so what's that one called again? That's a pivot. Good, and we'll use pivots to produce zeros below it. Okay, so what did we do? Well, we said let's take 2 times the first row. So beautiful, this stuff, this kind of math, and add it to the second row, and put that result in the second row. Replace the second row with that result. And then, to get a 0 in the third row, we'll take -3 times the first row, add it to the third row, and replace the third row with that result. The pivot, well, the one is going to, the one can be used to produce zeros below it, Solomon. That's how I know it's that's how I treat it like the pivot. I want to, and I want to have zeros below the 1. Well, actually, remember, this is an augmented matrix. So the pivots are going to come on the from here. I want to be a little bit. I got to be a little bit careful here. I got to be a little careful with how I say it. But I'm focusing. I'm not really worried about the right side. I'm worried about simplifying, and so my focus is on the coefficients of the variables. Let's put it that way. Okay. Now, remember what we're asking here. They're asking, I mean, we're trying to see if B is in the span of A1 and A2. Okay, so right now, I just want to see if it's possible. Okay, I want to see if it's possible. So I'm not even necessarily worried about going to reduced echelon form, but I am worried about getting the matrix in echelon form. Okay, so what I do is I'm not going to convert -3 to a 1. I'm just going to leave the second row alone, but I want to produce a 0 where the -18 is. So I'm going to take the second row and multiply it by -6 and add that to the third row. And put the result in the third row. And Binyam is right. Binyam is right. Look at the third row. Look at the third row now. Remember, every row in an augmented matrix, every row is an equation. So what's that bottom equation going to be? Well, it's going to be 0x1 plus 0x2 equals -2. Divahar asked, you need to simplify. Yeah, you do. Divahar, you at least need to get the matrix in echelon form. You at least need to get the matrix in echelon form. All right, good. But now, should I bother getting the matrix in reduced echelon form? Should I bother? No, definitely not. I don't have a solution. No need, since we know there's no solution. That's right, Matthew. So the system has no solution, therefore the vector B is not in the span of A1 and A2. The vector B is not in the span of A1 and A2. Okay. So What does this mean geometrically? The vector B is not in the span of A1 and A2. Geometrically, what do the vectors A1 and A2 live in R3, and the span of those two vectors is any linear combination of those two vectors. Okay? The span of A1 and A3 is any linear combination of those two vectors. So the span of those two vectors would geometrically be a plane. But Michael's right. The vector B lies outside of the plane. Okay, I'm going to go to the next page, if that's all right. Everybody's good? All right. Geometrically, this means the vector B is not contained in the plane spanned by A1 and A2. The span is any linear combination of the vectors. That's how a span of two vectors is defined. So that would form a plane in R3. And it's going to take a little time to be comfortable with this. I understand. But, you know, you will. Anytime we can support something with a geometric interpretation, it's helpful for sure. Are there any questions before we move on? Makes sense, Steve Har? I'm glad to hear that. I'm glad to hear that. I'm trying to pick good examples for you. All right, I'll stop the recording.